This conference will now be recorded.
All right, I'd like to thank everyone for joining. This is John Stewie, co-chair of the server project. CMEC is also online, who co-chairs it with me. It's 2 after, so we'll give it another minute or two before we get started. Okay, looks like I think we got critical mass now. I'll go ahead and get started. I have a fairly full agenda today. First, I want to start with some subgroup updates. Jiao, do you want to start and give a update from the NIC3 subgroup?
Can you hear me?
Yep, we can hear you.
Yeah, okay. Yeah, so I think the subgroup, I think the update is largely related to the a few activities in the OCP summit. First is we did first time join the OCP experience lab. It's first time for everyone, but I think 7 companies, volunteers from them demonstrate technology to the community. I think that's a very good try, and we also have some learning. We probably will publish those learning as well, and hopefully, I think overall I get a pretty good feedback from people around, and hope we can do this again in the future. And then the second is the subgroup did I think delivered 8 talks in the engineering workshop. In the summit, and the video and the slides are available in the link published by, I think, Michael from OCP Foundation. So please take a look if you missed them. And what else? I think we also published the result of the OCP NIC 3.0 adoption survey in both server or system suppliers and NIC suppliers. So this 24 survey return and pretty good turnout, and more than half of the survey return are from the new companies that never participated in the survey last year. So very good signal and good feedback. So which can be the base that the subgroup can work on in the rest of the year. So a couple thoughts in this subgroup discussion on the NIC is we probably see some value in the interop area. So that can be one area that the community can work on, trying to work with partner in industry, trying to see what's the problem and what's the value potentially in an interop program can bring to us. And the thought, high level thought is because a lot of companies are doing design, and many of them are showing their live demo in this month. So in the next year, there will be, I think, a pretty heavy validation work going on, and really to make the form factor compatible and plug and play is currently we do not think we have a line of sight to it, other than each system supplier trying to test multiple NIC, but we do not have mechanism to share the learning and backport those learning into the spec yet. So we are thinking about doing some kind of workshop to discuss this, and probably with that we may find a solution for that. So this is some quick thoughts from the OCP NIC subgroup.
All right, thank you.
Yeah, thank you, John.
Simac or Whitney, you have a update on the OAM subgroup?
We have presented the OAM spec at OCP Summit, and as we announced, we have created a subgroup around the infrastructure to build for the OAM. There's a mailing list and there are wikis. We're looking for people to register on the mailing list, so we know how much interest there is. Based on that, we will have weekly meetings or monthly meetings to go over a number of chapters for a spec for a OAM infrastructure specification. Whitney, any other comments you'd like to make?
Do you want to talk about the license? We will share the license information or link maybe in the wiki so people can have the license file and sign the license to join the group. And so we are under discussion to form the maybe monthly meeting for the OAM as well. But at the first couple of months, we may have more frequent meeting to discuss about the OAI related plan and also form the baseboard spec. These are the plan.
Okay, thank you. Originally it was an OAM subgroup that was changed recently to OAI to focus on the infrastructure, which includes the module. So if you see OAI versus OAM, the OAI is the infrastructure where the OAM is the actual module itself.
Right.
Yep. Next we have the ODSA group update. Bapi, are you online? Okay, I don't see him online. So we did have a ODSA track in the engineering forum at the summit. I think it went well. So the intro is on the wiki. So wiki server ODSA if anyone who wants more information on that.
Yeah, they have a workshop tomorrow as well in the Bay Area.
Yeah, it's 9 to 5 a.m. at the Samsung facility. I believe registration is now closed, but if anyone is interested, please send me a quick chat message and I will try to see if I can accommodate. This is Archana, by the way.
All right. Yeah, thank you, Archana. Okay. Next up, we have the Emmett 2 Accelerator module. How are you online?
Yeah, I am. John, how many minutes I have? Like, I have a slide which is 20 page. I just want to be in time. Yeah.
Okay. Yeah, say about 50 or 20 minutes for the M.2 and the Glacier Point. 20 minutes for both of them.
Yeah, two of them is up together. Okay, I can share. If,
Yep, you are a presenter.
Great. All right. See that?
Yep. Oop, it disappeared.
Oh, okay. I go to the.
It was up for a minute and then disappeared.
Okay. Seems like it does not go to the show. Is that okay?
I don't see it. Does anybody else see the screen?
I can see it.
I can see the slides now.
Yeah, I probably just stay in the normal mode. Don't go to the show mode if something is wrong. But yeah, if everyone can see the slides, I will start. So yeah, hi everyone. My name is Hao Shen. It's my pleasure to present the 3 hardware specifications we contribute to the OCP. One is the Glacier Point V2, M.2 accelerator, and the dual M.2 accelerator. So some of the background saying like Facebook is looking at the some of the workload that is not that is efficient on the CPU and seeking for the help for the accelerator hardware to comes in. Two of the typical workload. One is the AI, both like training and inference. We need a special accelerator to help to improve the efficiency. Like the OEM is have a lot of discussion on both training and inference. For the M.2 and the dual M.2 accelerators, we mainly focus on the inference side. And also another workload is for the video transcoding. Basically, like for the video stream, you need to change the format, codec, and the resolution for those videos. Those are some applications like a CPU is not effective, and we saw like a big value for the accelerator to come in. In terms of the machine learning, you can see like Facebook has a huge amount of the application on our main apps, like including the search, translation, facial recognition, ads, and news feed. Some of the recap of the video workload, you will see like currently all our mainstream apps supports video, and we will have more and more like applications like will include the videos. Those are the some of the emerging applications like we saw, like the workload keep increasing, and those are the two areas like we think the accelerator can help a lot. So some of the recap of the hardware Facebook is using for the AI so far before this OCP is including Bryce Canyon, Big Basin, Tioga Pass, and the Twin Lakes. So once the accelerator hardware comes in, we will see like a new groups of the hardware comes in to support those workload. Here is a rough introduction about the M.2 and dual M.2 form factor. So basically, like hardware specifications we contributed is based on those two form factors. M.2 form factor is an industrial standard. You can see like we choose the 22110 form factor. Meanwhile, we also provided the reference design for the integrated heatsink. So the heatsink, including the module, becomes a through. The difference comes from the components on there. Instead of supporting the storage, we put the ASIC and the DRAM on the M.2 modules, and it supports PCIe by 4 lanes. And we also define the UART and the JTAG, those debug ports on the edge fingers using the pins that is not defined in the M.2 spec, but is still compatible to the standard M.2 specification. During the investigation, we find out like the power and the area restriction of the M.2 is not suitable for some of the accelerator workloads. Like it's very hard to make a chip like to be able to put it at 22 millimeter wide. So the dual M.2 form factor actually works pretty well for most of our applications. Like this dual M.2 is 46 by 110 millimeters. Simply like you can think about it, put two M.2 form factors together with 2 millimeter pitch in between. So you have two sets of the edge fingers. It can put a much bigger ASIC and support higher TDP, and we can put more DRAM chips there, so to utilize the bandwidth of the DRAM. I will give more details in the later introduction. Okay, so here is a detailed breakdown of the M.2 accelerator module. You will see like we have the ASIC sitting roughly in the middle of the board, and the DRAM chips is on two sides of the ASICs. So this is a standard 20 to 110 form factor with 0.8 millimeter thick. Generally speaking, you cannot put more than 12 layers of the PCB lamination with this thickness. In terms of the component height, we set up height keep out zone as 2.5 millimeters on top, mainly because like the ASIC, including the package, everything will be higher, and the 1.5 millimeter height at the bottom. So you can see on the right hand side, this is the explosive view of the heatsink. So those heatsink is a reference design, like we contribute to OCP. You are free to use that or free to modify that based on your own requirement. The thing is, like we saw, by defining the heatsink, it makes the industry easier to provide a total solution for the system. Meanwhile, like a guarantee that we can cool down the ASIC effectively is because, like unlike the storage, the thermal power is very aggregated into the ASIC. In this case, it's not like distributed along the module. In terms of the power and interface, you will see the whole module, we are targeting to 10 watt TDP in nominal case. If you look at our spec, we do define several different power consumption range, depends on the thermal capability of your system. And in general, it should support a 264-bit LPDDR4X interface. On the right hand side, you can see like we define all the IOs at the which is compatible to the M.2 standard, using a lot of NC pins. Here include except the PCIe and SM bus we already have. We also define the UART JTAG. We also reserve the USB pins, but it's not required to support it in Gen 1.
Which key position have you picked?
Oh, it's M key.
M key. Okay.
Yeah. So another drawing describe more about the dual M.2. You can see like this is a 46 by 110. Same same thickness, same height keep out. The one thing I want to give you a little bit more flavor is about it's not used to support this dual M.2. You really need a proprietary connector, but this is a connector, something like we collaborated with Amphenol, which is already done. They have the part number. The thing is, like we put a two M.2 connector body together into one tooling. In terms of the PCB outline, I use the orange line to cross out some of the critical to function dimension where you need to control your PCB to be plus minus 0.05 millimeter instead of 0.01 millimeter. So that's two things need to be taken care of. Like if you want to use the dual M.2 connector, dual M.2 module, you need to use a special connector, and your PCB outline need to follow our drawing. This connector is backward compatible. You can put it in the standard M.2 modules in this connector without any problem.
In any of the two positions? Standard?
Yeah.
Any of the two positions?
Yeah. And in any positions, and the landing footprint is completely like compatible. So the same landing footprint, you can solder two single M.2 connectors or one dual M.2 connectors. The requirement is to be able to backward compatible to the M.2 application. So same thing, like we define the main slot. That means like one of the during the dual M.2 module, all the IOs will be all the like non-PCIe IOs will be only on the main slot. while like the second slot only provided the extra PCIe lane. So this dual M.2 module support the PCIe by 8 and the power lanes. So that means like during the design, like if you design the modules with if you design your PCB using this interface, then you can plug either dual M.2 modules or single M.2 modules in. So in the M.2 and the dual M.2 spec, except the some of the key bullets I mentioned before, we also defined the power transient spec. Some the details for the PCIe that the module we expect the module to support reset architecture, through information, the reliability and the compliance for mainly for the Facebook's requirement. So this is the hardware spec we contribute to OCP, and this is what we are currently doing now. We want the industry to give us feedback, or feel free to use that, and we communicate to see like how to make this better and evolve.
So have you coordinated with the PCIe SIG about any reserve pins you're using to make sure they're not defining those reserve pins in an incompatible way in ECRs? Because the PCI SIG controls those reserve pins. I'm worried that they'll have a conflicting definition that will cause damage.
Yeah. So far, like here's the case, right? We are also a member of the PCI SIG. We make the pin definition compatible to all the latest ECR that include some of the 1.8 volt I/O pins. However, we didn't contribute this to PCI SIG because so far for the accelerator, I think still the application will drive the silicon, and the silicon will drive the form factor. We still, that's also one of the motivation. We want to open this information, but we are not convinced like we still look like whether or not this is the standard spec. This could become a standard. We want to hear more feedback from the industry before we say we want to push that into the industrial standard, because there is another track on the PCI SIG talking about the next generation form factor. This one is not. This one is just what Facebook is doing now. For now, like if we want to have some accelerator modules we want to use, that's the one we want to do. Long term is a different discussion.
Okay, yeah, I'm just concerned that PCI SIG will come up with a PCR that's incompatible with this because they're not tied together.
Yeah, that's a potential concern. Yeah, I agree with you. So far, like what we can do is we will keep monitoring the PCI SIG and see how things goes. In the end, like what I saw, the PCI SIG is also doing some change, and we are open to the change also.
Okay.
Yeah, thank you. Good question. Next few slides, I will describe something related to the Glacier Point V2, the system. So basically, like Glacier Point V2 card is a carrier card we designed to support this the accelerator single M.2, dual M.2s. So in this card, we can put up to 12 single M.2 or 6 dual M.2s. It's either way you want to configure. So the Glacier Point V2 card will be plugged into the Yosemite V2 server system. So each of the Yosemite V2 sled will have 2 supernodes. One supernode is one Twin Lake CPU head node plus one Glacier Point V2 card. The block diagram looks like this. So you have each Yosemite V2 will have the shared NIC, and they will go to one CPU card. Each CPU card will connect it to the GPV2 card. So on the GPV2 card, we do have a PCIe fan-out switch to extend the 24 lanes from the twin lane card to the 48 lanes to support all the accelerator cards. So in this case, like the CPU will have their system DRAM, and each accelerator will have the LPDDR4X DRAM. This is an explosive view of the mechanical components on the Glacier Point V2 card. Yeah, if you see like actually like the system is including two PCBs. One is the riser, another is a carrier. So basically the riser card, the major reason for the riser card is like we want to shift the carrier card to the center of the sled so that you have the reasonable airflow on both the top and the bottom side. As in this time, like you need to put the modules on two sides to fit the total 12 modules in. All the other design is similar in the previous style, like the latch, the air duct is very similar to the standard Yosemite V2 plug-in card style. PCIe wise, as I mentioned, like we have now they are microchip, like the Microsemi PM8535 fan-out switch. So basically, like we have 24 lanes in, 24 lanes on the upstream port, and 48 lanes to the downstream port. It can be easily reconfigured to bifurcate to 12 by 4 port or 6 by 8 port in the downstream port.
So what triggers the switch to do that bifurcation change?
So basically, ideally, we want to, at the beginning, we want to fix the configuration. So basically, like you can save the configuration information in the card through, so that the BIC and the BIC can read the through information, know its M.2 configuration versus its a dual M.2 configuration. Then they can choose to load a different calibration file to the PCIe switch. That's the current plan. It do have the capability to dynamically detect what kind of card is connected into the slot based on the through information on each accelerator. So basically, we define a field in the through of each accelerator to claim itself, I'm a M.2 module or I'm a dual M.2 module. The flow is still under defining because it's a little bit complicated, since the M.2 does not have standby power. You first need to power it on, then you know whether or not it's an M.2 or dual M.2. So that's something like we prefer to make the system simple at the beginning, to just define the configuration of the carrier card and use the whole carrier card as a single. The whole carrier card will have a single configuration. Did I answer your question clearly?
In the space between the two connectors, you said there was
2 millimeters.
Yeah, couldn't the connector be designed to bring you aux power?
Yeah, if that's yes, definitely, like that's something we can discuss. So far, like I haven't defined any aux power on the pin area. That's something we can look at.
That would only work on the dual, it wouldn't work on the single.
Single, we don't have, I think we at most have 1 or 2 pin left. Yeah, but that NC pin is a potential, that NC pin is we need to keep close monitoring with the PCI SIG. Yeah, if we use too much of them, that could cause some unexpected could cause some potential concerns. But
So quick,
what I mentioned, that we are open to the change and figure out once we have more voice into this family, I think we have a stronger, we can impact the industry.
so quick question. I might have missed this earlier, but it's not two M.2 connectors side by side. They are different pinouts.
If I go back to Dual M.2, so basically this is a module.
Okay.
This is module pinout. You can see like I intentionally leave the second slot without any like non-PCIe, non-PCIe IOs, so that it's you only use one side. Yeah.
Right. So if you use one M.2, then you don't use the other one, basically.
No, from a system standpoint, you can support two separate M.2s.
You can support two separate M.2. This is a module pinout for the dual M.2. If you look at the connector net list, right, it will be exactly copy of the slot A versus slot B, because on the connector side, like the pinout is exactly the same, because we need to support M.2 module also.
Right, but you're missing things like the SM busts and.
No, so the point is the platform side is two separate M.2s. This is just the module saying the module isn't going to use the second set.
Ah, okay, got it. So then, but then the NC pins on the second connector then couldn't be used for other purposes, because you would defeat, a single M.2 module on the second slot.
Right.
Right.
Yeah.
Okay.
That's true. You only can, to be backward compatible, we have restrictions. But I think it's important. We need to be backward compatible to the mainstream. At least like a dual M.2 is still very proprietary. That's the purpose. Like we want to share this to the industry and to see whether or not that will be a good direction to go. Okay, so this is the I2C block diagram. What I want to say is like we do have a Snowflake microcontroller on the Glacier Point V2 card that serves a lot of management features. So you can see like for the major interface to the M.2 connector, two things I want to say. I use the 6 I2C master ports so that each of them have a 1x2 mux to each M.2. So basically saying if you use M.2, you only need to mux once to screen all the modules. If you use the dual M.2 modules, the dual M.2 modules will occupy those 2 slots. Then you don't need to mux at all. You have the concurrent access to all 6 dual M.2 modules at the same time. Meanwhile, I have an INA 231 hooked up for each M.2 slots. So that's the major path we use to monitor the power consumption and voltage to each module, which will be useful for the BMC power monitoring.
So what is Snowflake?
It's a TI microcontroller. So for the Yosemite V2 platform, the BMC is on the baseboard with shared by 4 slots. So each slot will have a microcontroller to offload those monitoring and management features. Yeah, if you want to have more details, you can look at the doc file of the specifications. Like that one has a more descriptions.
Okay.
So as I also mentioned, we do have the JTAG and the UR pins for each M.2 dual M.2 modules. How am I going to use that? Is basically like those pins will be muxed through a CPLD to the bridge IC. So basically, like the Bridge IC can use some Bridge IC can use the use this digital interface to send the command to the modules. If you want to do the at-scale debug, you have that capability to do that. Okay, that's all my talk today. One last thing I want to mention is like the reason we share. There's another reason we share this hardware spec is because we saw even in the especially in the AI side, we saw there is for the inference workload, we do want to impact the industry to provide a solution that is not that power hungry, that is very compact with enough DRAM bandwidth for our application. So it's not everywhere we need a lot of TOPS. Sometimes like we need a performance per watt and the small chips so that we can easily scale. Those kind of chips will be fitting on the two form factors I shared before, and that is a sweet spot we saw, but currently not a lot of people is having that solution. Everyone has a very big chip, so it's very important to hear the feedback from the industrial colleagues and to see what you saw and what do you think will be the future. Thank you very much.
Okay, thank you, Hao. Now, is this deck you've been presenting a new deck, or is this a
this is a new
deck?
I will send it to you.
Okay. Yep, and I'll get this deck posted on the wiki already. Are the 3 design specs for the single, the dual, and the module.
Yeah. Thank you.
Okay, thank you. All right. Yeah, so those 3 contributions are ongoing. If you have any feedback, feel free to send any feedback to the mailing list or to Hal directly. Next, we have a Tioga Pass discussion. So MITEC did present a platform that was almost following the Tioga Pass spec, and we decided we really needed to update the Tioga Pass spec to accommodate that. I think Whitney agreed to do that. Whitney, you have any comments on that, or is the spec available yet?
The spec is under review now. It's available, and then I can. Do we want to review today or maybe next time?
Yeah, if we can just review the changes, there really shouldn't be that many changes. So if we can review the spec real quick. MITEC already reviewed the server.
Yeah.
So if we can get any comments on the spec, we should be able to move forward that without having another work group discussion.
Yeah. Jonathan, can you? Yeah. I may ask Jonathan to help to present.
Okay, but can you present it on the screen? I can explain the changes.
Okay. I need to get back to my laptop. Or John, you wanna maybe move to the other topics? When I'm ready, I'll message you.
Okay. Ron, are you available to start talking about your Nestricom SmartNIC?
I did not get a commit from my engineering guys that they would be able to present, and they're not on the call. So we're going to have to push that out as I'd indicated to the April meeting.
Okay.
And so I will jump on them and get them to commit to the April timeframe.
Okay. That'll free up some time. Glenn, you want to talk about the Quantum Leopard submission?
Hi, John, can you hear me?
Yes, I can.
Yes. Okay, please grant me as a presenter.
Okay.
Can you see my screen now?
Yes.
Okay. Hi everybody. I'm Glenn from Quanta, and today I would like to present our contribution for the Leopard Cave. And this is our previous generation multiple node product, and this product already available in the OCP marketplace. So today I would like to contribute our design collateral and quickly go over what we contribute. So here we go. Here is our agenda. We will have a product overview, mechanical overview, high-level feature list, baseball block diagram, design file contribution, and the final one is available product in OCP marketplace. Leopard Cave is an ORV2 compliant multiple node compute system, and that include powerful dual Intel Xeon Echo 5 2006 600 V3 and V4 processor with the 16 DDR4 DIMM, and that can provide the impressive high density compute resource for in each node that can handle multiple events concurrently. And what we contribute is the design collateral, and the spec we reference is the Facebook server Intel motherboard 3.0 version. Here is the Leopard Cave mechanical traces mechanical overview. As you can see, it's include 3 nodes in 2OU system. It is a modular infrastructure allow simplicity and flexibility. You can add or remove building block as you need. Here is the high-level feature list. We have 2 skills that are available in the OCP marketplace. And here I show is the one of the skill, and you can take a look and welcome the further discussion. Here is the block diagram. And here is our design file contribution. In the electrical portion, we contribute the board file and the schematic of the baseboard and the riser or the TPM module. And we also contribute the component BOM and the manufacturer related file. In mechanical portion, you will find the related state file. In software portion, you can find the BIOS, BNC, CPLD, and the VR firmware binary file. And as I mentioned earlier, we already have the product in the OCP marketplace. So today, what we want to contribute is the design design package. And welcome to take a look and see if you have any comment or question. Please let me know. Thanks. That's my last slide.
Okay, thank you very much.
Yeah, welcome.
Yeah, so I mean, since this is going against an existing spec and the product has already been on the marketplace, this is just the design package. I have the files, but we can't post them yet until they finish up the licensing agreement. But we should have those, all the design files he posted to up on the wiki within a week or so. Okay. Whitney, are you ready now?
Do we have any other topic? My computer has some problem.
Okay. Yeah, we can hold on a little bit. The things we had kind of on the agenda to talk to if there's time. There's a SCM discussion with CMAC. Alibaba is wanting to come in with some Ali FPG or Ali DNN. I don't think we have time for. Is anybody from Alibaba that just wants to say a word or two about those or not? Okay. Part of that discussion also is it's very late for anybody over in China or Taipei. CIMAC and I talked about pushing the schedule for this call up 1 hour. That'll at least put it at midnight instead of 1 a.m. for people in Taipei or China. Is there anybody on the call who could not support moving this this forward 1 hour going forward? Okay. Yep, I think that's something we should do. Archana, are you still online? Oh, looks like she may have dropped. Okay.
No, I'm still online.
Okay. Can you go into the OCP schedule and move the schedule for this call up 1 hour?
1 hour? Yep, I can go ahead and do that.
So that puts it at 8 a.m. Pacific time. So
Correct.
We kind of don't want to go too much beyond.
No,
earlier.
I think that's going to be fine. Okay. And I appreciate that because we have a lot of people from Taipei as well as, I'm sorry, from Taiwan as well as mainland China on the call. And I know it's like midnight or 1 o'clock their time right now. So.
Yeah, I think it's only midnight now. In the summer, it gets to be 1 a.m. So that'll push that back an hour. Do everything we can for them.
Okay, I'll go ahead and move it starting next month. Mm-hmm.
Sounds good. There's also a Penguin chassis contribution. There's been a lot of internal email around. I don't think it's quite ready to come, but hopefully we'll get to that in the April meeting. Is anyone from Penguin Online if they have any words on that? Okay, doesn't sound like it. The other thing we had come up late was the NSPR wanted to donate a Mission Bay, Crane Mountain, and an Olympus 4S sled that we'll put on the queue for the April meeting. Does anybody from NSPR want to say anything about that this month? Okay, so it sounds like we are getting together a good agenda for next month already, just with the overflow from this month. Are you ready now, Whitney, or do you want to have CMAC talk about the secure control module?
Oh, I'd like CMAC to go first.
Okay, CMAC.
Okay, at the OCP Summit workshop, we introduced a modular building block architecture and through that discussed a module that encompasses all of the management and security features of a server. The slides should be on the wiki. If not, I'll present them later. John, you didn't mean for me to present it here, right? I'm just talking about it, right?
Whatever you have time for, whatever you want to do.
Okay, so the main point is we would like to standardize on an interface to this secure control module so that it is useful for all kinds of servers, single socket, dual socket, and many socket processors, JBOD, JBODs, JBOFs. So as a preliminary pinout for that interface, if you guys can provide feedback to that, that'll be very good. If there's enough interest, we will have a more focused meetings, perhaps in the form of a subgroup, to go and standardize that. A number of people have raised hands saying they're interested in building to that. It will be very good if we can have a common definition of that so it's useful.
Is that pin out in the slides you presented at the workshop, or is that a separate document?
The slide that I presented at workshop has a rough definition of the pinout. We keep working on it and refining it based on the feedback that we're getting. I'm welcoming any other kind of feedback before we publish the spreadsheet version of that.
Okay. Yeah, so that deck I will put onto the wiki. It's also on the past summits. Actually, everyone should have received the notification that all of the videos and all the available slides are on the Open Compute website under the events past summits. So what SciMac is talking about, I'm highlighting here. If you didn't receive the notification that these are all out there, that means you aren't on the mailing list. So definitely get on the mailing list if you didn't receive notification that these slides and decks are available. Okay, anybody have any comments on the secure control module? All right, sounds good. Whitney, are you ready now?
Yes, can you make me a presenter?
Okay, done.
Oh, I have to join from my computer as well. So while I'm joining, I roughly talk about the spec. Main change is the add ADIM support for the single site board. So basically, I changed the wording wise. For single site, we support like ADIM and also 16 version, and double site support up to 12. That's keep no change. And previously, the second difference is the voltage regulator. We didn't call out like which voltage regulator we're gonna use, and then we defined some requirement for the power, and so I think that's fine. I will just leave it as is. So basically, the main change is really just add the DIM. Like ADIM support for the single-sided.
Okay.
I think my laptop need a reboot.
Okay.
Yeah,
Well,
I tried to join. Yeah.
Yeah. Well, we're pretty much out of time. It sounds like the updates to the spec are very minor, and
that's right. Yeah.
It's nothing that I think would need a full community feedback on, because it's just changing the verbiage slightly to allow a single-sided board. One thing we try to do.
ADIM. Yeah.
Yeah, our 8DIM. Yeah.
Yeah.
And one thing we try to do when we get the base level specs is to make them generic enough that we can have multiple companies submit designs against that spec. This is a case where we have a design that was close to the spec but not quite to it. So we'd like to thank Facebook for being willing to go in and update the spec to allow the multiple companies.
Yeah, I think that's the direction for later. If we have like a main design to contribute that, one of the base spec maybe can be have the spec, or all the other spec can follow that base spec to allow that. Yeah,
it does take a lot more energy and work to write a good base spec that's generic enough to allow that. So it takes
that's right. Yeah.
Takes some extra work, but it's worth doing. Okay, I think that's all we have on our agenda today then. Does anybody else have anything they'd like to discuss before we close the call?
Hey, John, this is Bobby. I'm sorry I joined late at 9:30.
Good. Yep.
I just want to remind everyone, if you're interested, we have a workshop tomorrow on the ODSA hosted at Samsung.
Yes, we brought that up earlier. Thought that the registration was closed, but if you wanted to get in, to let them know, and they can probably squeeze you in.
Yep. Apologies again for missing the first half.
No problem. All right. I'd like to thank you everyone for attending, and a reminder that next month's call will be an hour earlier to help our contributors in Asia. Sorry. And everyone, have a good week.
Bye.
Thank you.
Thank you.